Hello. So here I'm going to show you how we can integrate this function. It's actually a definite integral going from 0 to 1 of 2 all divided by 2x squared plus 3x plus 1 dx by actually making it simpler by using a method called partial fraction decomposition that I used to think was really complicated. I didn't understand how to really integrate by partial fractions, but this is actually not going to be that hard at all. So what we want to do is, first of all, looking at the denominator, 2x squared plus 3x plus 1, well, that's kind of screaming to us to be factored. So if we try and factor the bottom, I think, so just looking at 2x squared plus 3x plus 1, that should factor actually very nicely. Right, so we try to factor that. Well, 2x squared has to be 2x times x. 1's got to be 1 times 1. And I think we do a plus and a plus, right? We go ahead and distribute this. We get 2x times x, 2x squared, and then we get a 2x plus x, giving us 3x in the middle, and then 1 times 1 gives us plus 1. So yeah, so now we're factored. So we know that when we add fractions, if we have the same denominator, we can just add the tops over that same bottom, over that common denominator. So kind of going, in a sense, backwards, if we can write, just looking at the denominator, let's not even worry about the integral for right now. If we had, let's say, some number, some constant a over that first linear factor of 2x plus 1, so a over 2x plus 1, and then if we had plus b over the other factor of x plus 1, well, to add these fractions, we would have to get a common denominator. Now, to get a common denominator, it's just going to be the product of our two denominators. It's going to be x plus 1 times 2x plus 1. But since we already have a 2x plus 1, right, over a over 2x plus 1, we just multiply a by x plus 1 over x plus 1. So what we're going to get then is going to be just x plus 1 times a. So we get x plus 1 times a, and then it's going to be over that same bottom of x plus 1 times 2x plus 1, and then plus, well, we're going to be adding b plus the factor of 2x plus 1, because we're multiplying b over x plus 1 by 2x plus 1 over 2x plus 1, so we get plus 2x plus 1 times b, and that's going to be all over the same bottom. But then, so we don't really care about the bottom right now, because if we go ahead and distribute this out, what we get is we get a times x, so we get an ax, and then we get a plus a times 1, so plus a, and then we get the b distribute, so we get plus b times 2x is going to give us, I guess, a plus 2bx, and then plus b times 1, so plus b, all over that same bottom. But now, look what we're integrating. We're integrating 2 over 2x squared plus 3x plus 1. Well, now, if we actually get a common denominator and combine our fractions together, what we're going to get then is this ax plus a plus 2bx plus b all over the same bottom, which again is all over 2x plus 1 times x plus 1, but remember, this is just the same thing as we have in our integral. This is 2x squared plus 3x plus 1, so therefore, if the denominators are the same, the numerator's got to be the same. So that means that this ax plus a plus 2bx plus b must be equal to 2. Must be equal to 2. And what we can then do is then kind of group the x terms and the constants together. So what we can say is we can factor, let's say, an x, right, from ax plus 2bx. So we would have, I guess we would have a plus 2b all times x, right? Because that gives us ax plus 2bx. And then we're going to have a plus a plus b plus a plus b. But that must be equal. It must be equal to 2. Because, again, this is this thing right here, right, is over this, but this is this. This is the same denominator we have right here, so therefore the numerators must be equal. So we can set this equal to 2. Equal to 2. And then, look at this. We have something times x plus again, a plus b is equal to 2. Well, look at our integral. We have 2 is the only thing in the numerator. There's no x's at all. There are no x's at all. That means that a plus 2b must be equal to 0 because there are no x's. There are no x's. So therefore, a plus 2b must be equal to 0, and that means the rest of it, a plus b must be equal to 2. And now we can actually solve this for the constants a and b. We can go ahead and, looking at a plus b equals 2, we could solve that for a or b. If we just subtract b from both sides, we get that a is equal to either negative b plus 2 or 2 minus b. And then we can just plop that in for a into the first equation, right? Plop this right in for a. So therefore, we have a is going to be 2 minus b. So we get 2 minus b. That is a, and then plus 2b is equal to 0. The parentheses there aren't even needed. We can go ahead and combine negative b plus 2b, which is 2b minus 1b, which is b plus 2. So we get b plus 2 is equal to 0, and then subtract 2, getting that b is equal to negative 2. So b is equal to negative 2, and then we can just plop that in here. We know that a is equal to 2 minus b. So a is equal to 2 minus b. What is b? Negative 2. So 2 minus a negative 2 is 2 plus 2. So therefore, a is equal to 4. So now we can plot these a's and b's right into this here, because we can write our integral, right? Take what we started with and write it as a over the first linear factor, once we factor it, plus b over the second factor, and now we know that a and b are, so our integral is going to become the integral, we're still going from 0 to 1, of a over 2x plus 1, but a is just going to be 4, so we get, is for 4 over 2x plus 1, and then plus b, but b is negative 2, right? So plus a negative 2 over x plus 1, I guess is going to give us minus 2 over x plus 1 dx. And now we actually know how to integrate, well, maybe, both of these, so we can basically split it, and now we can integrate piece by piece. So we can first integrate 4 over 2x plus 1. That's going to be a simple u sub. So if we just let's say u be equal to 2x plus 1, then what is du? We differentiate. The derivative there is just equal to 2 with respect to x. So 2 dx dividing by 2, we get du over 2, or 1/2 du is equal to dx. So that means that this first integral is going to become just the integral. We can make a 4 out front, and then also a 1/2. So 1/2 times 4 is just going to be 2 times the integral of just 1 over u du. But just 1 over u du. But again, u is going backwards. This 1 over u, the integral of 1 over u, is just the natural log of the absolute value of u. But we know that u is 2x plus 1. So that first integral just is going to be equal to, we get 2 times the natural log of the absolute value of u, which is 2x plus 1. And then for the second integral, again, the negative 2 can come out. Again, same thing, u sub. But in this case, letting u be equal to x plus 1, du is just dx. So we get negative 2 times the natural log of the absolute value of x plus 1. So we get minus 2 times the natural log of the absolute value of x plus 1. But since this is a definite integral, we're going to be then evaluating this from 0 to 1. So we plug in 1 first, so we get 2 times the natural log of, the absolute value. So 2 times 1 is just 2. 2 plus 1 is 3. So the absolute value doesn't matter now because 3 is positive, so natural log of 3. And then minus 2 times the natural log of, 1 plus 1 is 2. So that's just the natural log of 2. And then we subtract off what we get. We plug in 0. We plug in 0, though. We get 2 times 0 is 0. 0 plus 1 is 1. Natural log of 1 is 0, right? Because a log is an exponent, and we're saying e to what power is 1? Well, e to the 0 is 1, since anything to the 0 power is 1. So therefore, that's going to be 0. And same thing for the other part. We get 0 plus 1, again, 1. Natural log of 1 is 0. So we just get minus 0. Minus 0. So therefore, we just get 2 times the natural log of 3 minus 2 times the natural log of 2. We can actually factor out a 2 here if we want. If we factor out a 2, we get 2 times the natural log of 3, right? And then minus the natural log of 2, right? So if we distribute, we get 2 ln of 3 and then minus 2 ln of 2. But since we have subtracting 2 logs, same base e, and we know if we have a quotient in the argument, it's the difference of the individual logs. So in this case, we actually write this as a quotient, just a natural log of 3 divided by 2, which is the natural log of 3/2. So therefore, we have 2 times the natural log of 3/2. And there is our final answer. Calculator. Take care.